Okay, here we're going to be talking about relating polar and Cartesian coordinates. And Cartesian coordinates you've been graphing with a long time. This is that x and y that you've been dealing with. Now we're going to relate this and turn these into polar and go back and forth really. The first example we're going to take a look at is we're giving polar coordinates and we're going to go to Cartesian. So let's look first at the equations that relate these two. All right, the first thing that we'll note is that x equals r cosine theta, y equals r sine theta, r squared equals x squared plus y squared, and tangent of theta equals y over x. So what we're going to do is we're given, in the first example, polar coordinates, and we should remember that a polar coordinate is always expressed as r theta. Okay, so that being said, our r is 5. Our theta is half of pi, or pi over 2. So what I'm going to do first is I'm going to express my x in terms of r cosine theta. And so r in this case is 5. And then we have the cosine basically of theta, which is pi over 2. And then the y is 5, and then it's going to be sine of pi over 2. And this right here will actually get us to our answer very quickly. All right, so let's take a look at this. Well, what do I know about the cosine of pi over 2? Well, from the unit circle, the cosine of pi over 2 is just 0. And then the sine of pi over 2 is just 1. So this is something important that you probably should have memorized by now. So 5 times 0, of course, is 0. And 5 times 1, of course, is 5. So if we are writing out our polar coordinates, which were 5, and then I'm just going to write this as pi over 2 because that's what it is, its equivalent Cartesian coordinate is just going to be 0, 5. Okay, so that's the answer there for this first question. All right, now let's go ahead and take a look at the next problem here. All right, we are asked to find polar coordinates in the interval of theta from 0 to 2 pi with an r greater than or equal to 0 of the point given in Cartesian coordinates. So understand this is an x and this is a y. All right, and so we know a couple of things. The first thing that we have to find is our r value. All right, so we're going to have to find r, and we know that r is just equal to, I should say, r squared is equal to x squared plus y squared. So then we can say r is equal to the square root of x squared plus y squared. All right, so we've got enough information here. So if I write out r, I'm going to set it equal to the square root of 3 squared plus 3 squared. What is that? Well, that's the square root of 9 plus 9, which is the square root of 18, which I can break up as square root of 9 times the square root of 2, which is 3 square root of 2. So my r value is 3 square root of 2. Now, this right here, 3 is in the first quadrant. So I'm going to put Q1 there. I know that I'm looking at an angle between 0 degrees and 90 degrees. All right. Now, the next thing that I note is that I'm going to use this formula that says tangent of theta is y divided by x. So knowing this, I can say, well, what's the tangent theta of 3 if it equals 3 divided by 3? So then I can say, well, tangent theta equals 1. Tangent theta equals 1. And so since the tangent of theta equals 1, I can take the tangent inverse of 1 to get theta. Well, this is fairly simple to do because in 0 to 90, there's only one place that happens. And that happens at the value for theta equals pi over 4. Now think about it. Where in 0 to 90, or 0 to pi over 2 in this case, so I can write that in there too, 0 to pi over 2 radians, where does it occur that the tangent is equivalent to 1? Where are y and x the same, in other words? So look at the unit circle and you'll find that. All right, so theta equals pi over 4. So let's write out what we know. If in Cartesian coordinates we are dealing with 3, 3, its equivalent polar expression is going to be 3 square root of 2 and then pi over 4. So that's what it would look like then in polar coordinates, and really there's nothing to it. Again, applying those formulas that we discussed at the very beginning. So as always, I hope this video was helpful, and remember, like and subscribe.